All right, ladies and gentlemen, this is a short video to show you how to do the PhET activity for polarity and repulsion that we're about to do. What you're going to do is you're going to watch this video. You're going to fill in all of these blanks here and add to that. And once you've done that, you're going to show it to your teacher. They're going to give you this activity, which you will then finish. All right. So this is all about bonds and polarity, and it's all based on electronegativity. So if you recall from our work earlier, electronegativity, actually, where is it? There it is. Electronegativity is the attraction for electrons in a bond. Right? So the higher the number, the greater the attraction. So glass has a structure like this. It's got silicon and oxygen. And so it has a lot of these oxygen-silicon bonds. All right? So what we're going to do is you're going to turn this page over and you're going to find the periodic table of data. And then you know that oxygen is element 8. And so the electronegativity will be 3.44. So then you'll come back over here and it will be 3.44. Then you're going to do the same thing for silicon, which is element number 14, and the electronegativity is 1.9. So electronegativity 1.9. Now, then you are going to do what is called an electronegativity difference, or a delta electronegativity. So the delta electronegativity is equal to the absolute value of the electronegativity for oxygen minus the electronegativity for silicon. And so absolute value means that it's always going to be positive. So 3.44 minus 1.9. All right, so I'm going to pop that into the calculator. 3.44 minus 1.9. And that's going to be 1.54. That's the electronegativity difference. Now remember, the electronegativity difference is always positive, okay? Because it is an absolute value. Now scientists have worked out that there are different bond types depending on the electronegativity difference. So if you have an electronegativity difference of between 0 and 0.4, then you have something that's called a non-polar covalent bond. And in a non-polar covalent bond, the electrons are shared equally. Doesn't matter if it's 0 or if it's 0.4, the electrons are shared equally. If you have a electronegativity difference that's basically greater than 0.4 and up to 1.7, then you have a polar covalent bond. And the polar covalent bond, the electrons are shared unequally, mostly around the higher one. And then if you have an electronegativity difference of greater than 1.7, you have an ionic bond. And an ionic bond, you have a cation, or a positive atom, and an anion, or a negative atom. And that's because one element loses electrons. It could be more than one, and one element gains. So the one that gains ends up being negatively charged, and the one that loses ends up being positively charged. All right, so 1.54, right? Let's pop that back. So 1.54, we come down here. 1.54 is clearly between 0.4 and 1.7, so that is a polar covalent bond. All right, now, polar covalent. Now, you go to your PhET settings. First, you go to the simulation itself, which looks like this. The two atoms looks like that. Click on partial charges, okay? And you can click on bond character if you want to. It's not necessary, but you can. So then you go back and you set your PhET the way it is here. So atom A is one click from the right for more electronegativity, okay? That's because atom A is oxygen and the electronegativity is very high. So we're going to set the electronegativity very high. We're going to go in here and we're going to slide the slider to there, okay? Then we're going to go back. We're going to check atom B is 1.9. It's less electronegativity. So we're going to set that slider to halfway, which it is right there. Then we're going to zoom in on these, and remember, A is oxygen, the one on the left is oxygen, and B is silicon. So then we're going to draw in our dipole, okay? So the dipole is that black arrow there in the middle. So we're going to draw it in just like it is. Okay? Now remember, this one was electronegativity of 3.44 and this one was electronegativity of 1.9. So the dipole is always pointing towards the biggest one. Then we're going to do this thing called partial charges. And you see you've got that little negative there on the end and the little positive on the other. Oops, I'm moving them around. I don't want to do that. Okay, a little positive on the right-hand side. So we're going to put that into our drawing as well. So we have a partial negative here and a partial positive here. All right, so this is the dipole, okay, and these are the partial charges. Now, what do we figure out when we do that? We figure out that the biggest electronegativity is going to be partially negatively charged. Right? That's the first thing we figure out. And we also figure out the dipole points to the negative charge. Atom. The one that's partially negatively charged. Okay, now that's it for the notes here. Show that to your teacher that you've done this and you know how this thing works, and we'll get the rest and you'll move on with the activity.